Yeah, so I hope you can hear me and you can see the screen. So I'll try to do this a little bit faster because we are running quite low on time. So the demo is actually product of work of Dragoslav Prasad and Igor. And I'm here just reporting what we sort of built as a platform under the IRIS pre-proposal to sort of evaluate some of these techniques of cooperative dynamic spectrum access that we are talking. And of course, given that this is all done in a testbed, right, we sort of focused on implementing this platform for experimentation with the spectrum sharing techniques on both Orbit and Cosmos testbeds, right? So again, we heard enough about SCMs from Carlos. Again, the focus is really just on enabling exchange of these SCMs between various participants in the sharing, and sort of trying to look at various algorithms that can be built on top of the SCM compatibility tests that one can come up with, right? The other component that was actually quite important in building the platform for evaluation was the network interaction language, or something that was heavily used during the DARPA Spectrum Collaboration Challenge that we participated in. And very interesting aspect of that component was the fact that it was actually developed by competitors, or designed and developed by competitors in the Spectrum Challenge, as a language that sort of was used for coordination between these competing networks or collaborating networks in the challenge itself. Now, of course, the core of that is pub/sub service that's used for exchange of messages between entities. And we just adopted that as is, and sort of made sure that we can exchange our SCMs through such a network, and of course add a number of configuration messages and events that we need to support dynamic spectrum coordination. Now, this is sort of a picture that shows what is possible. One thing where we sort of looked at the alternative ways of coordination, right? Because remember, it's pub/sub, which means that pretty much all the communication goes through the pub/sub coordinator at the very top, is to sort of enable also peer-to-peer communication between nodes in order to be able to look at these distributed techniques, not just in centralized. And so, as I said, SIL protocol, a number of different messages. We really don't have time to go through all of them. But so I would rather just sort of illustrate how this whole coordination effort goes. So if you look at the leftmost side of the diagram, right? So the first network comes in, and we have these entities that are sort of coordinating the network access. So that doesn't necessarily mean that the nodes are talking to each other, but rather that the coordinators or wireless domain controllers are exchanging messages. They register with the pub/sub server. The server informs them what's available in terms of other entities that are participating. And then you have this notification and the exchange of SCMs, where each of them can individually or in coordinated fashion decide whether compatibility exists or not, and what needs to be changed in order for system not to interfere, devices or domains not to interfere with each other. Now, just to illustrate, and remember this demo, and by the way, this is not a live demo, just wouldn't risk it. So it's actually a recording of a demo. And another thing also is, unfortunately, we are not yet fully operational due to COVID, so it's really not easy to do experiments in New York City where a number of students would be allowed to walk around doing experiments. So we focused really on the Orbit testbed, which is where we can do remote experimentation without anybody having to be in the facility. And so just to illustrate, we are using very simple algorithm to sort of illustrate the capabilities of the platform itself. So please don't read into the results. There is no performance measurement yet that makes sense to report. The assumption here is that there are existing domains, and you know, they are participating in communications. New domain comes in, it has a number of nodes in there. So in this particular case, we have existing domains or existing TXRX pairs. New domain comes in, it has two radios. One is we are designating here as a TX and RX, but you can easily extend this to to sort of two-way communication where both are transceivers. And sort of the first thing they do is they register it as a new domain, right? Then they sort of say, okay, we are going to try to see our compatibility when we exchange the SCMs, right? We'll try to see compatibility between receiver and all the transmitters that are participating in the networks, right? Then that's followed by the exchange or compatibility tests with the SCMs of the transmitter and all the other receivers. And only then we will evaluate the compatibility test and choose the frequency and power allocation that new network or new pair of nodes in this case can satisfy and cooperate. So now, this is an animation of the same process, right? So we have 3 wireless domains that are participating in this. We have 3 time slots at which they're joining the demo. And again, as said, we are mapping this onto the orbit grid. And so this is the representation of the orbit grid. You have ceiling nodes, they're acting as the base stations, right? To think of it as base stations. And then we have these corner units, which are our massive MIMO racks, and we are not using massive MIMO for this particular demo. It's really, we're just using individual software-defined radios, both in the grid and in the corners of the grid, right? So think of it as base stations are on the hanging off of the ceiling, and the corner units are acting as the mobile devices. Now, in this particular case, we are just assigning the capabilities of radios as having 3 channels. We are focused on 1.99 gigahertz, 2 gigahertz, and 2.1 gigahertz, right? And this is just as an example of what's going on. So let's say the first link comes on. This is now a recording and video of what's happening actually. So the idea is that once the node pair of nodes comes up and wireless domain registers with the topology controller, it exchanges messages, sees that there is nobody else in there, and sort of chooses its own frequency freely. And as I said, the default frequency is 2 gigahertz, right? And eventually establishes the communication. The channel starts, or the exchange starts, and the transmitter and receiver exchange messages, right? Now, after some period of time, the second pair of nodes comes in, and again, this is not just a pair of nodes, it's an entire domain is starting to come up. And of course, the platform allows you to play with the scenarios where the domain negotiates, or every time the new nodes come in, the domain negotiates, and of course, in both centralized and distributed fashion. And so again, the same story, right? The node sort of comes on, registers, but now it discovers that there is another domain already operating, right? It actually connects, establishes a connection between 2 domain controllers, right? They exchange the SCMs, which will come eventually, right? So this is where it discovers that there is a other domain already operating, right? Then start sending SCMs around, and of course, this is the SCM that you already saw. Carlos showed a few examples of how the SCM looks like. This is XML representation. And then, of course, it computes the compatibility and concludes that there is no way that it can actually operate at the same frequency, and therefore selects the lower channel, right? And then finally, the third one comes in, and again, it gets a little bit more elaborate in the sense that now you have to sort of do 2 peer-to-peer connections, exchange a number of SCMs between the nodes, and of course, go through this process of sort of looking at compatibility tests between multiple transmitters and receivers. And here you actually see the number of the 4 tests that it needs to perform in order to figure out compatibility. And again, decides to go onto the channel that is at 2.1 gigahertz. Now, interesting thing in this particular case was that there was out-of-band interference, and of course, SCMs can actually capture the out-of-band interference, which in this case was caused by the use of different software-defined radios, which have much sloppier front ends. Now, as I said, this was a very simple algorithm showing how the coordination protocols would work. We have a number of ideas and algorithms that we are testing, of course, on a much larger scale. Now, obviously, the benchmark algorithm is, and we heard the talk by Wahid and a couple of other people mentioning that distribution is actually what we need to deal with. So we have the ideal algorithm, which is sort of think of it as an oracle, which is capable of doing the optimal allocation of spectrum and power, and of course, maximizes some utility of the network in the network. Now, of course, those are highly complex algorithms, and they're non-trivial cost of reconfiguring the whole network. Then we have the sort of variants of that, which are greedy or ML-based, that sort of try to reduce the complexity, and of course, have a trade-off in reduced performance. Now, mostly what we are really interested in is this notion of sort of local reconfigurability and fully distributed algorithms, which scale much better. And of course, that scaling involves all sorts of issues with how do you propagate and how large is your local neighborhood, and how efficient is your assignment of spectrum and power use. Now, with that, I will finish and just start this is actually the whole demo shown in a single video, and take any questions if there are any.